Welcome everyone. It's really good to be here again. We've only just had Martin give us a talk, I think, last Thursday, just before the weekend. So this year we're really starting off with a bang. Thanks to Ziv. We're very privileged today to have Adjunct Professor Dr. Zhengrong Shi with us, a man who actually needs no introduction, a bit like Martin. If you don't know who Zhengrong is, you can read his bio. I'm not going to take up any more time. I'm just going to say welcome, Zhengrong. It's a real pleasure to have you here. Looking forward to what you got to say.
Thank you, Alistair.
Thanks very much.
Thank you. Thank you. Good afternoon, ladies and gentlemen. Martin, and is really pleased to be here again. And also notice there are many new faces. And about a month ago, I wrote an email to Alistair for catch up because I'm here for a few weeks holiday. So Alistair said, okay, could you come to the center, maybe give us a thought about your opinion or your like close to the industry information about what's happening in the industry. So then I just thought really my strongest feeling this moment, not just in China, also globally, PV is really driving energy transition. There's no joking. So it's really happening. So I just want to share a little bit about my view on this topic. And we all know, for energy, like whether it's green or dirty or whatever, and there's many choices for consumers. So, but we as renewable energy people, we love wind, we love solar, and so on. And there's the coal or nuclear, many choices for consumers. But from consumers' point of view, they think a lot differently from what we think. They want energy has to be safe, so reliable and affordable. So there may be green is good, but if the green is expensive, sorry, I cannot afford it. So that's actually for all of us in the room has been battling, this game in the last, like probably 40 years, more than 40 years since Martin founded this lab. And there's others, I guess we all know, like conventional energy also causes a lot of problem, resource depletion and, carbon dioxide emission. And this carbon dioxide emission really causes this climate change. And many of us already feel the climate really changed. In Sydney, like I was in Melbourne last Thursday, the temperature was 45 degrees C. Then within 30 minutes dropped 15 degrees C. So I couldn't understand this phenomenon. And also in China the same. So this weather just become ridiculous to predict. And still a lot of people talking about controllable nuclear fusion, which is also claimed to be disruptive technology. And before I joined Martin's center group about 30 years ago already. So I did my master degree back in China. I work on laser interaction with thin film of laser, because for high power laser you need to, the chamber, the laser need to, reflecting with inside, then shoot out to get 10 to the 12 per square centimeter, 10 to 12 joule per square centimeter energy density to really try to fire this fusion. And I was working on this thin film damage, because before laser even shoot out, the thin film is already damaged. So that's something related. But now the laser power is already went up to 10 to the 13. And I heard 2 years ago, US built 19 rows of such lasers with a diameter of 4 meters, but still couldn't fire, And China plans to build the next one, double the routes, 38 routes. So see if can be fired or not. And so as we know, is far away, from now. And but what is available? We already see wind, solar, energy storage, and electric car vehicle, and a smart grid, and basically is integration of all this technology together. I think technology-wise, we are there. More or less we are there. And just some graphs. I think most of you probably already see from here or there. And in terms of capacity or installation capacity of solar, last year in 2018 again is over 100 gigawatt, and the price of module is already around 20 US cents per kilowatt hour, and electricity cost generated from solar is already around 2 US cents per kilowatt hour. And recently I heard because there is oversupply of solar project developments in Australia, all these developers try to sign PPA with Energy Australia or Origin Energy and so on. So you're talking about the PPA around 5 cents, 5 Australian cents per kilowatt hour, and so is really low. I think is happening already. We all believe. I believe we all agree. Photovoltaic electricity will become the cheapest, electricity generation technology. And although the industry, went through all this crisis, and policy change, material supply, oversupply, trade barrier, financial crisis, and so on. So eventually, we emerged as the one of the strongest industry since in the new century, I think. And we as solar people very happy to see that. And this is one of Martin's slides I used. See, again, show the emergence of grid parity, and it's really happening in many countries, even in China. In China, 2019 is first year government is removing the subsidy. Okay, basically for market we have two different market sector. One sector there's totally no subsidy, and another sector is there's slightly, maybe only few cents of subsidy, mainly try to promote a new technology and a new product into the market. And a virtual power plant with solar and energy storage system is also happening. We integrate the wind, solar, microgrid, batteries, and so on. Energy management system, even online transaction software and technology is all happening. Technically, I think it's all there. It's all just a matter of when market will take off. So this company, can also take off with their sales and volume. Because I knew a few companies. One company in Sydney is actually Module Power. I think many of us probably heard of this company. They try to do exactly what I show here. There's another company in Silicon Valley, SunVerge. So they also working on virtual power plant. Try to aggregate residential, homes, so they can manage for you the PV energy storage, when to sell, when to buy, and the transaction in between, and so on. So because the market has not yet taken off, so many of these companies have some difficult time because raising money, they have to burn money. But I think eventually, maybe in another, say, 5 years' time, when market really, takes off, I think this company will boom, And I showed this graph many years ago, and because many people say PV cannot be grid base load energy because of this interruption, and but if we think globe as a whole, sun rises from the east and travels to the west, but the electricity electrons transmit from west to the east. So all the cables from each country can be connected globally. So I think this is just a matter of politicians' decision and determination. And in China, the state grid, the chairman of state grid, Mr. Liu, and the chairman, Mr. Sun of SoftBank, they have been talked since 2 years ago because back in 2011, I met with Mr. Sun in SoftBank in Tokyo. He had a similar idea at the time. He said Mongolia government gave him some clean coal mine. He could burn the coal, clean coal, cogeneration with PV. Then he asked me, Dr. Shi, if we install 20 gigawatt in Mongolia, what sort of price you can sell to the grid? Could you do it at 6 cents or lower? So actually we spent half year to work with his team, and we say 20 gigawatts, we can do even 5 cents. But now definitely is 2 cents, no problem. So I think this global renewable energy grid is really attract many big guys and big companies and politicians in the world this moment. So China's state grid is already promotes these ideas, and actually in China already happening. There's a 3 hours times difference between Shanghai and the West. So most of these solar farms were built in the West. So actually, like 9 o'clock in the evening in Shanghai is still 6 o'clock in the West. They actually can transmit this electricity generated by solar, to Shanghai. So this type of trading between provinces, and the cities is already happening in China. And also another exciting thing is like, I still have, I'm still a major shareholder of Asian Silicon, which is producing 20,000 tons polysilicon in Qinghai. So now that the government talking to the company, we can directly sell the electricity powered by PV to a factory. So that's really exciting news at this moment. And also, this is just a weathercast, and I think Alistair and myself, we co-supervise a student, Charlie. He worked on the project a few years ago. If a wind project in New South Wales itself, instability is 14%. When he included Victoria, ACT, and New South Wales, instability went down to 4%. So this is just like a weather pattern. I found one for U.S. Weather forecast pattern of a day. You see like, when New York is raining, Minneapolis is sunshine. So we integrate the whole globe, whole country together. Actually, instability, of this, sun insulation is quite stable. So the bigger the area, the scale, actually, the solar generation is very stable. So that's the point I want to make. And now I want to just go through briefly about what's happening with the supply chain. Because you look at the photovoltaics module price dropped so dramatically. When I went to China, module price was like $6 per watt, but now module price is 20 something cents, per watt. So what happened during this in the last 20 years? So first of all, is this polysilicon. Initially when the polysilicon started in Germany, Japan, or China later on, was like 9 rods, 9 rods or 12 rods, 24 rods, 36 rods, but now it's 48 rods. So this we see this, the pairs. But when you increase the rods, the energy consumption, has been reduced dramatically because the more mass inside actually conserve the heat, thermal energy there, and so less energy lost. So this is what happened in I think it's Asia Silicon's plant is 48 rods, and per kilogram energy consumption become 42 kilowatt hour. So start from 250. And also the wafers, same thing. The wafer has been, no matter is multi-casting wafer or single crystal wafers, they all improve dramatically in terms of single casting or pooling capacity, and also the thickness of wafers, quantity of wafers, and efficiency-wise. So now we're talking 3 grams per watt. So not long ago, we still talked about 5 grams per watt, but now it's already dropped to 3 grams per watt. So, and more importantly, everybody in the room, we should feel very, should congratulate ourselves, especially congratulate to Martin. And the technology, from this group is really leading the commercialization and the industry. And you look at PERC, mainly is P mono PERC. And in 2018, the new installation of PERC is, I think, is around additional 40 gigawatt. Next year will be another, probably 60 gigawatt. So very soon the entire production technology will be converted to PERC. So with efficiency now is around 21.5 to 22.5% efficiency. Many companies already adopted select emitter together with the PERC. So and especially for select emitter, we also need to attribute this to the contribution of polluter technology, which was co-developed with university and Suntech. So including equipment, laser equipment, and so on. So is being widely adopted by the industry. And also the efficiency, this morning I just heard there's a new record being broken, is 24.2% for PERC. And 2 weeks ago was 24.002 or something. So it's really the industry sales, keep, break the records. So that also tells the industry really improve the efficiency significantly fast. And again, it seems to the industry is very clear with a roadmap, okay? Because from initially multi plus reactive etching, but this is still an issue. With now there's a competition of mono wafer, of multi wafer. Multi wafer, there's some challenge with now with diamond wire to slice multi wafers. You have to somehow etch in the surface, okay, to improve light trapping. So whether you use reactive ion etching, or is people more preferably prefer chemical etching because it's a lower cost, and RIE is the PVCVD reactor. So there's a mono wafer, because mono wafer cost is coming down significantly, is easier to achieve high efficiency and so on. So the industry is already plot this roadmap here, because from industry point of view, they can not only pursue the efficiency, they also need to consider the cost at the same time, also the investment, because they're already putting a lot of money, invest in production lines. They don't want to get rid of all the equipment and install the whole new line. So that's the challenge, is always want to hang on with the old equipment with some addition of new equipment and keep efficiency going up without adding too much investment and or cost. So, and apart from that, HRT is sort of becoming one possible direction for future high efficiency, is because what's beyond PERC has been greatly discussed within the community in China. And some people believe HRT is the next generation, and some people believe TOPCon is next generation. But both seems involved with N-type wafers. And at this moment, P-type mono wafers still prevail. And we believe in this year, 2019, from wafer type point of view, probably 60% will be mono wafer and 40% will be multi. Because for multi modules, mainly will be exported to countries like India or South America and so on. So actually in China, people prefer mono wafers, certainly in Japan, Australia, and Europe. Yeah, Shingle is the next one. Although the production line, fully automated production line is already there seems some IP issues with SunPower or what's another company in US is Celeria, And early last year, or the year before last year, I sent multiple emails to Martin, asking Martin, I got the impression there seems no IP issue with Shingle. Then Martin figured out, I sent the email to Martin before I went to bed, and when I wake up, emails there with 5 or 6 patents, as early as 1968, right? So there seems no patent issue, but still something going on, and but the production lines is already, And what I feel more excited from my point of view really is, China's industry PV is modernizing PV equipment, because when I went to China back in 2001, everything was imported. Okay, that's for the first production line. Like a PECVD from Rothenroth, from Chemnitz, and from MPC Japan, from Italy. All the equipment was imported. And for the second production line, I realized there's some diffusion furnace and so on could be purchased locally. But now it look like 80% equipment, if not 100%, depends, what do you want, is all made locally. Especially is all automatic. Okay, it's all automatic and fully automated production line. So this really is amazing. This is one of the also important factors driving the cost down and driving efficiency going up. So also 5 years ago, China also transformed from the largest manufacturer into the largest application market of PV. So as I said, in 2017, China's installation was 53 gigawatt. And with some policy change, in 2018, we thought it could drop to maybe below 40 gigawatt, but actually still end up around 45 gigawatt. So it was really, a great progress, in applying PV for the country. And now, like the Bureau of Energy had numerous meetings in the last few weeks, and 2019 we believe we're certainly over 55 gigawatt, if not above 60 gigawatt. So the market is coming back. But having said that, the industry is again experiencing the difficult moment because of this price reduction along the supply chain. For example, polysilicon price dropped dropped probably by 40 to 50% in the last 6 months. Okay, so or in other words, 6 months ago, all the polysilicon manufacturers, they had a gross margin of 50%, but now it's come to about the borderline. So I think industry will have a few months or a year to do something dramatic, to lower the cost again, maybe have some margin. I think for manufacturer point of view, if margin around 15 to 20% is gross margin is reasonable, anything above 30% is probably not going to be sustainable. So because of that, China, PV is becoming one of the highlights in China. From many, this is Boston Consulting Group that did all this analysis. PV in China as an industry is leading the world, and also this is last year is the 19th Congress of China. There's few industry like wind, solar, high-speed train and a rocket. is like a proud industries, from China's point of view. So it's good to see that wind and solar are there. So after here, I would like to talk a little bit about because the industry is maturing, very fast, and just purely from our point of view, is there any innovation opportunities, for engineers or scientists to work in this industry. I mean, if you look at from product point of view, for conventional solar panel, I mean, in the last 50 years, it did not change that much, the structure-wise. It's glass, polymers, cell, and aluminum frame, and so on. And especially, they're very thick, very bulky. And I tend to think, why was that way, okay? Why the design was that way in the beginning? Maybe in the beginning, like 40, 50 years ago, solar cell was so expensive, maybe more expensive than gold. We got to protect them, pack them properly. And so it really didn't change, although the efficiency goes up a lot and the cost dropped down, significantly. And that's why this is like, the product. 4 years ago, there was a group of people, that talked to me. Then we started this, and basically just try to get rid of glass. And of course, this, there's many this similar product in the market, but I would say this is probably the first series one in terms of quality, accreditation, durability, cost, and so on. So basically, the team spent fair bit of effort to work on this, polymer materials to make it happen, and especially, it's passed all the certifications. So like IEC, and UL, or JET, and all these certifications. So, and at this moment, the applications, solar roofs, mainly they target these tin roofs, metal roofs. Actually, in Australia, even there's few big projects they're talking, and Maritime Museum, the one we did with Pluto some years ago. Probably the next building or somewhere is a historic heritage building. They couldn't handle the weight. They just signed the contract a few months ago, and it's going to put on 300 kilowatt. I think probably we'll get it done in March or April sometime. And I was told when it's connected, the Ministry of Energy will come to cut the ribbon. So that's what I heard. And so you can basically, for this installation, you can happen very easily. You can either glue or bonding chemically, or you can use bolt to screw on, or use others. And you can use a facade. I mean, for this, doing facade is quite simple. I mean, you can do all sorts of facade, like particularly like the middle one. I mean, it doesn't look like a solar panel, and it's just a conventional brick. And this is what happened in Spain, and they actually put this on the wind pole. And the Gold Wing, when I send this photo to Gold Wing, they say, okay, we got so many windmills, they would like to do the same thing. And also the solar tie, the team here in Sydney, they're working with CSR, the largest building material company. They want to work exclusively, with the company to promote this product in Australia, because it's so simple. It just you can use bolts. You don't need an engineer. Handyman can get it installed, quite quickly. And this is a project that's very interesting. We did it in Switzerland. It's on the surface of a sewage plant, because the sewage plant, from time to time, they will do this maintenance. They can't have a permanent installation. So what's the mechanism here is they can retract. They can retract the panel when they want to. Okay, so they retract the panel, spread the panel, and you can do this with roof, with sunshades or awning. It's just make it entirely. You can parking if there's snow in Europe. Just parking the panel. Of course, this is just some aesthetic thing. You can make it more commercial, and in the garden or something, make it easier to do. And this is another type work which you can do with this product, because they just launched. They will launch. They already have a single car. They have already launched a single carport a DIY. You can do it yourself, like 2 guys with 3 hours. You can get it done. And this is a 2-car port. Because electric vehicle, EV, is getting more and more popular in China, US, and in Europe, not quite yet here. But getting charging is going to be a problem. If everybody is charging the EV in the evening, then the grid won't have enough supply. So we believe there must be, the PV can definitely play a role here. So for example, on the left, if we have storage, lithium-ion battery storage together with charging, we can charge the car anytime. This can be also shared with different people. And the right is the imagination, could be different shape. Imagine like for kids, like they're born in millennium, right? Or later 90s, they drive sports car, EV, and come on campus, there's no sun shade. How about press a button, some shape of a solar panel? Spread out, right? Park here for 5 hours, and you get charged 3 kilowatt hour or 4. And I think, it will happen. Yeah, this is the interesting paper actually Martin shared with me some time ago. Is Toyota actually did this experiment, for 2 years, I believe, and they put on 1.3 kilowatt this skin on the car. Did the experiment for 1.5 years. So every day they can, generate about 3 kilowatt hour. Can power the vehicle. They did a lot of experiment, So people will say, well, is really the car is going to be in this shape? And actually, Hanergy, you probably know, Hanergy has been trying to produce a prototype car using CIS thin film technology. And but whether it's in this particular shape or the shape I mentioned early on, I guess it can serve the similar purpose. And also in this paper, the statistically, 70% people, they don't drive the car that much every day. Mileage is less than 40 kilometers per day. So only weekend it drives more. So in that case, we can charge 5 hours. Every kilometer hour will give you mileage of 5-6 kilometers. So can drive is not just like a theory. And these are the SUNMAN product being applied. This is Australia. It's a very high profile installation actually, although it's not a lot there. And is what's this? I forgot the name. Is Barman? Yeah. And this again, the medium power or micro power has been becoming increasingly interesting in the space of Internet of Things, and so on. So because in China, Internet of Things is becoming hugely popular these days in terms of investment and commercialization. I can tell you that every 2 weeks there is a forum on Internet of Things. Okay, many famous professors and CEOs from various countries come here to give a talk. So, but when they talk, they're always talking about this mini power and how to solve this mini power. Because for many sensors, and if you want to promote Internet of Things, then we need to print the chips into the objects. So the objects need a power. So they need a power for 24 hours, and all year long, many years. So that's something people always think about it. And I become interested in this particular technology, beta-voltaic. And I actually, early last year, again, I sent a letter to Professor Green, asking for, beta-voltaic, and if he's interested in pursuing this. And what Martin did, again, I sent a letter to him in the evening, he replied in the morning. He sent me a dissertation which he did back in his graduation, back in Canada or Queensland? Yeah, Canada. So that's the thesis he did back that time. And I said, okay, I'll ask the right person. So and at the time, so he already did that work. And because I just found this, because of, as I said, I went so many Internet of Things talk and people talking about micro power, and we started to do some research on what are the possible technologies to achieve this thing. And one of the technology pop up is beta-voltaic. It's actually exactly the photovoltaic. Photovoltaic will use the photons as a radiation to generate carriers, and but in this case, the beta is a radiation, is high energy electrons. Is less harmful than alpha, and other strong radiations, nuclear radiation, and of course, it's all due to isotope elements. So we use a radioisotope, to, in this case, beta in particular, which can be relatively easily to shield, and to generate carriers in p-n junction cells, so then we can constantly generate power without any reliance on sun and others. And here's a little mechanism about the different radiation, alpha, beta, gamma. There's a paper, plastic, steel, leads. So the shearability of different material. But what is important, you look at tritium and nickel 63. The half-year lifetime is like nickel 63, 100 years, and 12 years for tritium. And it's very long lifetime. We don't need to worry about when to charge it and so on. I believe Martin's work was for the purpose of a pacemaker at the time, but now is I think it seems to regenerate some interest in this direction, and I think it's because especially we could also produce this isotope material in the laboratory. We can produce this material by CVD or so on, and also there's optimization about from a sales point of view. There's a response to the radiation and the structure and also packing and so on. So because from our point of view, I just feel this direction is good from academic point of view. Still a lot of work and process need to be explored, and from a commercial point of view, is really have massive commercial value. Especially with upcoming of Internet of Things, and also medicals. Yeah, this actually is already a U.S. company. They're working on this direction, and they call nuclear battery for pacemaker, for power. It's exactly for power supply of sensors, and it's hugely expensive, and it's about $5,000 or $6,000 for this little chip. So I just wonder if the center, if we have capacity or interest to pursue this direction, I'll be very interested to work together with you guys. I think that's all the thing I want to share with all of you, and basically just give an overview about what happened in photovoltaics and the industry this moment. And I think we are the industry is indeed entering subsidy-free stage, and it's already happening in China, in Australia, and in many places. So, but with cost of solar is not an issue. What else consumers, want? So that's why I think there remains a lot of innovation opportunity for technology and product development. So from a consumer's point of view, or BIPV, and all this little thing, So, and of course, there's also some thoughts or ideas for to tap the center's capability. Can we do something or leveraging our foundation to do something more and in the future? Thank you very much for your patience.
Thank you so much, Dr. Shi. It was great. Questions?
do you think with the projected demands for PV, the projected demand for PV that's happening globally, China will be able to meet that demand in manufacturing?
Well, I guess certainly if it happens so quickly, it wouldn't. So it takes time to progress, yeah.
Other questions?
Zhengrong, thanks so much. Interesting to see now the BIPV. I mean, in the past, the argument for BIPV was that, well, with photovoltaics being expensive, you could put it into the building and help displace some of the costs of the building material. I'm beginning to wonder, though, now that we're sort of the other side of the cost-effectiveness of photovoltaics, now we're cheaper.
Yeah.
Is photovoltaics getting to the point where it could be the cheapest building material around, or am I still dreaming?
No, I think BIPV, attracts a lot of more attention here. In China, I would say this moment, because there's a group of people, they're very passionate about it, because exactly as you said, the cost is coming down so dramatically. And I think it's not just for BIPV, for PV as a say, people even consider how to integrate the PV with thermal insulation, okay, with other things together as a material. So I'm not sure whether it will become the cheapest building material, because building materials, if there's no other functions, but as a combined building material with all other functions, it could be the cheapest, and not just the build investment, also operation. If it become, yeah.
I was very interested to see your structure, the cover over the sewage, big shading system.
Yes.
I mean, I won't go into the details, but at my place, 20 square meters of solar panels,
Yeah.
20 square meters of solar panel on my place versus 20 square meters of shading over my deck.
Yeah.
The solar panels, 5 years ago were much cheaper than the shading system on my deck. So, I think I think photovoltaics as a mass-produced product could help the building industry improve its cost effectiveness.
Sure, yeah. I think Renata made a comment, a piece of mirror or glass is more expensive than panel.
Yeah.
Yeah.
Yeah, please.
This might be a little bit outside the area of your interest, but how does the demand for solar compare to the demand for coal in China?
Well, I think of course the coal still is a major a source of electricity generation in China. I think in China now still maybe around 70% electricity coming from coal, and but the good thing is Chinese government is really try to change this situation, because Xi Jinping actually has a slogan, we call the blue sky battle, okay, blue sky battling. So this moment in northern part of China is winter time, people had to heat their room. Before it's always use a small coal stove and so on. So that caused a lot of smog in Beijing and Tianjin and those areas. And 2 years ago, the government tried to crack down, okay, convert all this little coal stove into gas burner. But then, this time last year there was so many families that suffered from coal because there's not enough gas supply. So that's why they realized, okay, convert to gas is not the answer. Convert to electricity, the electricity burner is the ultimate way. So that's why there's all sorts of technology being product being commercialized, for PV in sector, PV like a PV plus heat pump, PV plus heat storage, and all this new product and technology is now being developed and try to support the market. Thank you. Thank you.